Hi, I am pictured on the left there, and my name is Cadet Luke Martin, and those are my project partners Crystal Terrio and Connor Howlett. We are Team SOAR, which stands for Stapler Operation Aid Resource and represents our mission to build a stapler assembly device to aid workers at Occupations Inc. Occupations Inc. is a nonprofit organization that employs persons with disabilities to assemble products like stencils, staplers, and earplugs. One of the most challenging projects at Occupations Inc. is the assembly of their heavy-duty stapler. Currently, Occupations Inc. only employs a single worker that is capable of reliably assembling the stapler due to its difficult assembly process. The two most challenging steps of the assembly process for a heavy-duty stapler are aligning two separate pinholes while compressing a spring. Oftentimes, workers would quit learning the assembly process for the stapler because the alignment was so difficult and frustrating. The stapler is composed of 10 major parts: a rubber base, a stapler base, a small pin, a small spring, a stapler body, a stapler feeder tray, a large spring, a staple press, a large pin, and a handle. The current assembly process for the heavy-duty stapler is broken into two parts. First, the attachment of the stapler handle to the stapler body, and second, the attachment of the stapler handle and body to the stapler base. To attach the stapler handle with the large spring and staple press to the stapler body, the current process relies on a large and heavy aid device to compress the large spring and align the pinholes. As I am about to show, the workers must compress the handle and, while compressed, insert the large pin. After attaching the handle to the stapler body, the part must be taken out of the device and moved to a separate workspace to attach the remaining parts. This is the end of the first step and the beginning of the second step. After inserting the staple feed tray, the worker must then freely compress the small spring and align the second pinholes to attach the stapler body to the stapler base. As you are about to watch, there is no support or guide in this step of the assembly process, which makes the alignment of the pinholes extraordinarily difficult. In addition to difficult spring compression and pinhole alignment, managers at Occupation Inc. highlight the lack of ergonomic design in the current aid device and the inefficiency in the two-step process, which also prevents the ability of workers to remain seated throughout the entire assembly process. With these problems in mind, Team SOAR set out to engineer a new stapler assembly aid device relying heavily on computer-aided design software and 3D printing technology. This allowed us to print and test prototype after 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 prototype until tolerances for pinhole alignment were finally met. However, the 3D printer did provide a set of challenges. The 3D printer could not print a device larger than 12 inches by 12 inches by 9 inches. Because of this limitation, we were forced to print 6 pieces that dovetail together to form the complete device, as shown here. Our stapler assembly device allows for the entire stapler to be assembled in the device to hasten the assembly process, provide a guide for small pin alignment, and to prevent the worker from having to move between steps. Also, thanks to 3D printing, we were able to print an ergonomic handle based on personal preferences from workers at Occupations Inc. Let's watch the SOAR device in action. First, the stapler base is inserted into the device, which is fixed by the geometry of the aid. After inserting the stapler feed tray into the stapler body, a cut on the back of the device is used to guide the stapler body during small spring compression for pinhole alignment. When the device is seated properly in the aid, the pinholes are aligned and the small pin can be inserted. After the body is attached to the base, the handle is prepared for attachment, which requires the emplacement of the large spring and staple press. After the staple press is inserted into the stapler body, the aid's handle compresses the large spring, aligning the second set of pinholes so the large pin can be inserted. After the handle is attached to the stapler body, the stapler can be removed from the device by pulling up on the handle. We took our device to Occupations Inc. and taught their employees how to assemble the heavy-duty stapler using our new device. Previously, one worker was able to assemble 1.9 staplers per hour using the old process, but was able to assemble 8 staplers per hour using our device after only 1 day of using it. Not only did our device increase the efficiency of the assembly process, it decreased the difficulty. Another worker, who was never able to successfully assemble a device using the old process, was able to assemble 4 staplers in an hour with our device. The SOAR device will allow for current Occupations Inc. workers to earn higher wages because they are paid based on productivity. The device will also allow for Occupations Inc. to meet increased demand for the heavy-duty stapler by hiring more workers who couldn't previously assemble the stapler. Thank you for watching, and a special thank you to our project advisors, Colonel Bettner and Major Fox, for their time and constant mentorship. Also, a thank you to those at Occupations Inc.